Lesson 9.4, Graphing Sine and Cosine Functions. Our essential question: how do you explore characteristics, stretch and shrink, translate and reflect graphs of sine and cosine functions? Standard 9.4, number 1, Graphing Sine Functions. We already went over all of the vocab and the definitions and the formulas for graphing. Let's go ahead and graph. So first, to graph, we need to identify the amplitude and the period. So here's our sine function. We know that sine has the a of 4, and the b is what's stuck to x. Our b is going to be 1. So we have identified our a and b. After identifying your a and b, we're going to find our amplitude, and amplitude is the formula, the absolute value of a. So my amplitude is the absolute value of my a, which is 4. So my amplitude is a 4. What does that mean? That means that I will be going 4 high off of the middle. Now let's go ahead and look at our period. So what does period tell us? Period tells us how long the repeat segment is going to last. So your period equation is 2 pi all over the absolute value of b. So I've got 2 pi all over the absolute value of my b is a 1. So I have 2 pi all over the absolute value of 1 is 1. So 2 pi divided by 1 is 2 pi. So my amplitude tells me how high I'm going to go. Period tells me how long a single repeat segment is going to go. So the entire segment is going to be 2 pi long. Then we have our 5 points that we need to find. So we have 5 key points. Those 5 key points in our sine had, the first was your x-intercept. Your first x-intercept was at the coordinate point 0, 0. Your second key point was another x-intercept, and it had a formula. It was this formula. So we're going to place our b, which we know to be 1. 1/2 times 2 pi all over 1 gives me pi. So that is our second. So here is our first, here is our second. And now we need our third key point, which was also an x-intercept. Sines have 3 x-intercepts in a single period. The third x-intercept formula looked like this, and we're just going to plug in our b value, which we know to be 1. 2 pi divided by 1 is 2 pi. So we have our 3 x-intercepts. Fourth is going to be your max, and he has his own formula. And your fifth will be your min. He also has his own formula. They both require a and b. So plugging in my a and my b for my max. My b is a 1, and my a was a 4. So multiplying, I end up getting my max and my min. My b is a 1, and my a was a 4. So multiplying. So I have my max and I have my min. So I need to make sure that I can count as high as a y value of 4 and as low as a y value of -4, which means I need to rescale my y's. So there's me scaling my y's. Now what about my x's? Looking at the x's, the highest x value I have is 2 pi, and I do have 2 pi there. So we're good to go. So let's go ahead and graph all of our 5 key points. So first, starting with our x-intercepts. Here's my 0, 0. I have pi 0, and I have 2 pi 0. I need to continue the rest of my x-axis. I observe it's at every whole pi value. So continuing through, every whole pi value is going to end up having a x-intercept as well. Now my max. My max is at pi halves 4. So here's pi halves 4. And my min is 3 pi halves -4. You said your period lasted from 0 to 2 pi. So this is the repeat that I need to continue the other way. So it's also going to go, we start here, it went up to 4, 0, down to 4, 0, up to 4, and we're out of space. So it's up to 4, 0, this will be down to 4, 0, up to 4. So every pi value had one. We're going to go ahead and connect these. And do they go as high as 4 on all the bumps? They do, as low as -4, and it looks to be an even repeated. You've just graphed your first sine. Now before we move on to the next problem, the last part of the question says to describe the transformation. So our A and our B tell us how much we're stretching and shrinking. So our A and our B are our transformations. Because A is 4, A is the vertical stretch or shrink. Because it is bigger than 1, this is going to be a stretch. So this is a vertical stretch by a factor of 4. B is your horizontal, and since B is not bigger or smaller than 1, that meant there was no horizontal change. So there is no horizontal stretch or shrink. Let's go ahead and graph your second sine problem. So first to graph, we need to identify A and B. A is always the number in front of the sine, so my A is a 1/4. The B is always the number in front of the X, so my B is a 1. To be able to graph it, we first have to find our amplitude and our period. Amplitude is a formula, and amplitude is a formula that is the absolute value of A. My A is a 1/4. So this is the absolute value of 1/4, which is 1/4. So my amplitude is 1/4, which means it's only going to be up as high as 1/4 from the middle. So now I need my period. How long is the segment going to be before it repeats? Period is a formula. It is 2 pi divided by the absolute value of B. So I have 2 pi divided by the absolute value of my B is a 1. So this is 2 pi divided by the absolute value of 1 is 1. 2 pi divided by 1 is 2 pi. So my problem is going to be 2 pi long, and then it will start repeating again. After I have my amplitude and my period, I need to find my 5 key points. Sine has 3 x-intercepts. So our first job is to find the 3 x-intercepts. The first one's always at the point 0, 0. Your second has a formula. Your third also has a formula. So our B's are on both of these. B is 1. So solving for our formulas. So we found all 3 of our x-intercepts. We found 3 of the 5 key points. Our last 2 key points are the max, which is a formula, and our min, which is also a formula. B is 1, our A's are 1/4. So plug it into our formula. We found our max, and we found our min. So graphing, we need to make sure that our period can last at least 2 pi, and I do last at 2 pi. My highest y value is going to be 1/4, which will fit on this problem. So let's go ahead and scale it so that we can see where the 1/4s are. Plotting our x-intercepts, 0, 0, pi 0, and 2 pi. That is our 1 period, which means that's our 1 segment before things repeat. I notice I have whole pi values. So let's continue through and make sure all whole pi values are represented. So we have all of our x-intercepts. Our max is at pi halves 1/4, so here is our max. Our min is at 3 pi halves negative 1/4. So this right here is our 1 period. This is what should be repeated as we continue forward and backward. So I'm going to be 0, up 1/4, 0, down 1/4, 0, up 1/4. I ran out of space. So up 1/4, 0, down 1/4, 0, up 1/4. I'm out of space. So this is my value. Here's my sine. The last part of this question says to describe the transformation. So our A is our vertical stretches and shrinks. Our B's are our horizontal stretches and shrinks. So since our A is a 1/4, this tells us that we have a vertical stretch by a factor of 1/4. And since my B is a 1, this means that we have no horizontal stretch or shrink. So it's no horizontal stretch or shrink. Our last problem. So I have a sine that I'm supposed to be able to graph. First, A is 2 and B is pi. I need to find first the amplitude and the period. So let's go ahead and find your amplitude. And amplitude is an equation, it's the absolute value of A. So my amplitude is the absolute value of 2, which is 2, which meant I will go as high as 2 from the middle line. If my middle line is the x-axis, I need to be able to get as high as 2, which means I'm going to need to scale this again. How long will the repeated segment be before it repeats? That's my period. So this is 2 pi divided by the absolute value of b. My b is pi. So this is 2 pi all over the absolute value of pi. That needs to be positive. So it's 2 pi all over pi, which gives me 2. So that's telling me that my segment is going to be an interval of 2 before it starts repeating. And I don't have just a plain old 2, which means this x-axis is going to have to be rescaled. So widening out the old scaling, we said we need to rescale both our x and our y. So there's me widening out all of our scales. Well, how high and low do we need to go? We have no idea. First, we need to find our 5 key points because that will tell us. Sine has 3 x-intercepts. Your first x-intercept is always at 0, 0. The second x-intercept is at a formula. And your third x-intercept is at a formula. They both require b, which is pi. So plugging in for our formula, so we just found all 3 of our x-intercepts. Those are the 3 of the 5 key points we need. Point 4 is your max, which is a formula, and our min, which is also a formula. Max and min both require a and b. A is 2, b is pi. So I just found my max, and I just found my min. So we need to make sure that we scale appropriately. None of our values have pi's involved, which means this is an xy axis with no pi's. The largest x value that I need is 2. So we need to make sure that we get as high as 2. So let's go ahead and scale our x values. Our y values, the largest y value we get is 2 and negative 2. So we just need to make sure that these are also counted. So I'm going to skip count these by halves so that they're large enough. Okay, x-intercept number 1, x-intercept number 2, x-intercept number 3. I see I'm at whole values, so I'm going to continue doing the whole values all the way down the x-intercept, all the way down the x-axis. My max is at 1/2, 2. My min is at 3/2, negative 2. My period lasted a full 2, so here is, I ended at 2. So from 0 to 2 is my period. This is the segment that repeats all the way up and down the line. So that is what I need to do. Amplitude. I notice from the midline it goes up to 2. That is my amplitude, how high it's going to be. So I'm going to continue. So I was 0, 2, 0, negative 2, 0. This would have been at 2, and I'm done. There's no graph left. So 2, 0. This would have been negative 2, 0, 2. It's already at 0. So I'm going to go ahead and connect these values. There's my sine graph. Now I just need to describe the transformation. So your A and your B describes the transformation for you. Because my A is 2, A does a vertical stretch or shrink. Because it's bigger than 1, it's a stretch. So this is vertical stretch by a factor of 2. B, which is pi, is going to be our horizontal. So this meant we had a horizontal change. Remember, horizontals do reciprocals. So if I were to reciprocal this, it would be 1 over pi, which is smaller than 1. So this is a horizontal shrink by a factor of, the reciprocal was 1 over pi. It was a shrink because this is smaller than 1. There were 3 problems left on the page for independent practice. Please take a look at those.